One of my friend asked this question. Generally, the reinforcement pattern in junction is given the top bar bend downward and the bottom bar bend upward. Can we make this as an alternative because of the conditions in the junction? The top bar upward and bottom bar is also upward, or sometime the top bar upward, bottom bar downward, which is the ideal cases to study or apply in the practically. That's the important thing. Before going this, we should study the shear mechanism at the junction. Otherwise, it will not give the proper solution for the question. First, I would like to write this pattern. So this is the element at the junction. What are the possible shear plane in this junction that we have to see? When you apply the force here, this is straight to come down, so the shear plane may exist like this, and there is a possibilities of rotation also. So for that, to avoid that rotational or torsion, that one more plane will be developed like this. If you are applying the force, there is a possibility, since it is a fixed rate, there is a possibilities that your some amount of horizontal forces is also there. Okay, these are the possibilities. So that vertical forces is also there, horizontal forces is also there, moment is also there, according to the equilibrium conditions. Then you see this element clearly. In this element, there is a possibility of a shear plane. Just I wanted to write like this, adjacent areas, and there is a possibilities of a shear plane like this, and the possibilities of shear planes are like this. In conceptual mode, if I wanted to write, this is the idealization of the shear element of this particular junction. Okay, these are the shear planes which is develops. Most likely what we do is we provide the reinforcement which is supposed to cross the shear plane in perpendicular direction. That is the ideal case, but always it is not possible. Ideal case in the sense we have to provide the reinforcement perpendicular to this plane. So this will be the perpendicular, and what is the perpendicular to this? This will be the perpendicular. See, strictly speaking, how we have to provide here, we need to provide like this. So for this plane and for this plane, so each plane making 90-degree possibilities, correct? So this plane, this is making 90-degree. For this plane, this is making 90-degree. But ideally, this is not possible in all the time in junction. It will take a lot of time, and as well as fabrications is also not so easy. So better we provide the right angle hook. Here you draw this, you provide the hook here till and bend down. You should cross and touch this plane, and one more, it should go and don't touch this, and you should proceed this. This make the angle, say theta. This is the contributor towards the shear resistance. Okay, and of course this length is contributing towards bond development. Bond development. So now you are understood that the reinforcement, if you are providing the pattern which is shown here, it, it may not touch the shear plane. It may not touch the shear plane. See, this gap is there. It is coming here and it is bending upward. So the chances of shear crack will develop. And at the same time, is that only the things is that it is contributing, the only the shear is the contributing towards that junction? No, development length is also contribute. You should have the idea of a development length. The development length, whatever LD that we are referring as, it should have minimum length of the LD. The LD is given as pi sigma s by tau BD. Tau BD is the shear strength of a concrete. That is a bond stress, that what we generally shear strength of a concrete. So the contribution towards that is generally how we calculate. We know moment, we know the shear forces in any junctions. In any junctions, we know moment, we know shear force, we know the horizontal also. Here this moment and shear proportion, whatever that you are having, moment is nothing but the force into distance, V is nothing but a force. So length you will get. So that length and L0 is a possible available length of a reinforcement. Maximum that a hook you can provide from the face. Okay, so that length you have to add it. This supposed to not more than this equation. 4 tau BTD is actually okay. This is supposed to not more than this equation. So based on this equation, your development length is calculated. Based on the plane, you are providing the reinforcement pattern, bending downward or bending upward. Okay, so this is how we have to decide. So better to avoid upward bending. If possible, provide downward bending only, and make alternative bars a slightly 1 inch gap. Just means to provide, just provide one more bar here, alternative bars like this, so that concrete can go inside. So instead of providing, how come I really not understand that if you are bending upward, how the congestions will be avoided? Okay, anyway, we bend downward and make some slight changes here. Just 1 inch, you just shift this reinforcement so that the space will be created. Alternative bars I'm talking about, right? So you do that, the problem will be solved.